Okay, welcome to today's video where I'll be talking about resistive forces. And the main one of this is going to be drag slash air resistance. So first, let's define what a resistive force is. A resistive force is a force that opposes an object's motion. Typically, it comes from the air, which is why air resistance is the most common of these. And the basic equation for these is Fr is equal to negative BV. This B value is like the coefficient of drag or air resistance. It's basically like the coefficient of friction except for air resistance. Now, what you know special about this is that it's based off of this value V, velocity, meaning as something increases in velocity, its air resistance goes up. So the first thing I have to talk about that's like really relevant comes from this, the direction. Direction is really important when we're talking about forces. And at the same time, it's not. What matters is that you keep the directions consistent with what you're doing. And whether or not you set FR equals minus BV or FR equals BV, and then you just subtract FR is completely up to you. As long as you have it such that FR opposes the direction of motion. That is the only real requirement. Okay. And next thing we have to talk about comes down to how it interacts with gravity. So let's say we have something that's first falling. Actually, let's talk on two parts. As it's going up, if you throw an object up, it has two forces acting on it. That's Fg and Fr. And so it's accelerating downwards with mg. Now, what do you think Fr is? Do you think it's positive or negative? That's right. It's also going downward since it's opposing the object's motion. So since the object is going up, that means air resistance Fr is going down. So we can resemble this as plus BV. This is how much it's accelerating downwards. Now, as it's going down, what is it doing? That's right, it's going to be mg minus bv this time because the resistance is going to be going up, so it's going to oppose this acceleration down. Okay, so now the next important thing you have to talk about in terms of its interactions with gravity. I don't know why my eraser is doing that right now, it's being weird. It comes from the existence of this m value, mg minus bv. So I'm sure when all of us were first asked a question like, oh, what accelerates faster? And a 100 kilogram block of steel dropped versus a 1 kilogram feather. Actually, a 1 kilogram block of steel. Um, and then I'm sure a lot of us are surprised by it's the same in a vacuum. It's not the same when we have air resistance. And the reason why it comes from the fact that with M, actually it's easier to just show with the equation, MA equals mg minus bv. This is it while it's falling. There's this m value here, right? And as you increase mass, the force of gravity gets bigger. And for bv to equal it or be significant to that mg value, it has to be bigger. An easier way to show is just divide by m. You get a equals g minus b over mv. So as mass increases, the impact of resistive forces goes down since they scale with velocity. Okay. So now let's talk about uh, how its motion is going to work. So the main important thing I have to talk about is terminal velocity. So as the block falls, as it gets quicker, its velocity is going to increase. And once the velocity reaches a point where it's high enough, you're going to notice that this b over mv value is going to equal g. And at that point, it's going to have no acceleration, meaning it's at its terminal velocity, its max velocity while it has air resistance. And you might wonder, okay, what if I throw it so that it's above its air resistance? Well, that means the B over mv magnitude is going to be greater than the g, meaning it's going to decelerate until they're equal again. That's all of the real ideas you have to know. Now it comes down to standard application. So let's say we have a question. and we have something that's falling, and it's falling with air resistance. The question says like it's currently falling with an acceleration of 1/2 g. What is its current velocity? Well, let's go solve for that. So F equals ma. The F's values are Fg minus Fr. I like to keep all my forces as positive values typically. I like to keep them inherently positive, so I'm going to say minus Fr equals ma. And that means that the Fr value itself is just going to be standard BV. So we get mg minus BV equals ma. And we get A equals G minus B over MV. And we're looking for when this A value equals 1/2 G. So we can just plug that in. 1/2 G equals G minus B over MV. I'm sure you can see how we do this already. So we get is minus 1/2 G equals minus B over MV. Now we get V is equal to M over 2B times G. Some questions, you like a similar question, except it's going to say that resistive force is minus BV squared or cubed or something. It's not anything special. You're just going to have to apply like the same process, same reasoning, and just solve through it. Okay, and there's one last thing I'm going to talk about in this video, and that is going to be how to derive the velocity of an object falling with air resistance. This is going to be a big derivation you have to know, and I know that many people might find it challenging the first time they try to do it. So we're going to start with the same point. F equals ma, Fg minus Fr equals ma, mg minus bv equals ma. Now what we're going to do is turn ma into something different. We're going to say mg minus bv equals m dv dt, because dv dt is equal to a. Now, this next part is the crucial step you have to know. We're going to move this dt over, and we're going to divide by mg minus bv. You might wonder, why? Why are we doing that? It's actually quite simple. What we're going to do is set up a double integral. Now, we're going to integrate both sides of the equation. In order to do that, what we need to do is get all of one variable on one side of the equation. So dt needs to go on this side, and all the v's need to go on this side. So we're going to move this bv over by dividing by mg minus bv. So what we end up getting is dt equals m dv over mg minus bv. We're already almost ready to, well, actually, we are ready to set the integral. So we can integrate both sides. dt equals the integral of mdv over mg minus bv. Now what we can do is say, we can quickly turn this part into t equals m times the integral of mg minus bv times dv. This might seem like really hard to integrate at first, but what you must realize, and this is going to be a common pattern, is that this is just quite literally the derivative of natural log. The derivative of natural log, so ddx of ln of x is equal to 1 over x. So this is just going to be the form of some of the derivative of natural log of something. And we have to apply the chain rule. So follow with me here. The ddx of natural log of 2x, let's say. Actually, no. 2x plus 1 And we're going to use the chain rule. So this is just equal to 1 over 2x plus 1. And then we're going to multiply by the inside of it for the chain rule. We're going to multiply the derivative inside, so times 2. So this gives 2 over 2x plus 1. Right, you following along? So we're going to undo this process over here. 1 over mg minus bv. It's going to be its original form is going to be natural log of mg minus bv. We can just plug this inside in there. So, but when you take the derivative of this, what you get is natural log, or not natural log, 1 over mg minus bv times minus bv. We don't have a minus bv here, so we're going to have to multiply by bv. So I am running out of space. Of 1 over mg minus bv times minus bv. In order to keep this as a 0 value, what we're going to do is also multiply by its inverse. So that's multiplying by minus 1 over... wait, actually, we don't need this v. The v is the variable. Sorry about that. It's not being multiplied by minus bv. It's being multiplied by minus b. Sorry about that. So this is 1 over b. And we can factor out this minus 1 over b. Okay, I'm going to move my work onto another page because I'm kind of running out of space. So this was the crucial step we were just on. Control C, next page, Control V. Previous page. Here, Control C. Okay. Just move this over. Oh, whoops. Okay. And what we're going to do is keep the minus b here. We're going to factor out this minus 1 over b because it's a constant. So that what we can guess that this is equal to minus m over b times the integral of minus b over mg minus bv. I forgot to write the dv here. It's dv. And this just equals the natural log of mg minus bv times minus m over b. So what we got is that t equals minus m over b natural log mg minus bv. Okay. So now it's just going to be up to basic arithmetic and math from this point. Oh, and don't forget the constant c. Since both of these have a constant c, since we integrate both sides, I'm going to say is that t plus c equals minus m over b ln mg minus bv. And we can pretty easily say that the starting situation was just that it started, for simplicity, we're just going to say it started from rest at time t equals 0. So you get, if you plug in those values, 0 for t, we get c equals minus m over b times the natural log of mg minus 0. So you get is that t minus m over b ln of mg equals minus m over b ln of mg minus bv. Now we're going to divide both sides by minus m over b. We're just going to do some basic arithmetic. And so we get is that minus b over m t plus ln of mg equals ln of mg minus bv. And I'm gonna take this over to the other side again. Next page. Now raise both sides to the e. So we get that e to the minus b over mt plus the natural log of mg equals mg minus bv. And this can be rewritten as e to the minus b over mt times e to the ln of mg equals mg minus bv. That's just using the basic exponent rules. And so this becomes mg times e to the minus b over mt equals mg minus bv. Subtract mg from both sides, so we get mg to the e to the minus b over mt minus mg equals minus bv. What we're going to do is factor out mg. We can factor out minus mg from both sides. Or not from both sides. We're going to factor out minus mg from here. So we get minus mg. It's 1 minus e to the negative b over m t equals minus bv. Now divide by minus bv, or by minus b on both sides. We get that v is equal to mg over b, parentheses, 1 minus e to the minus b over m t. Okay, so what does this value mean? We're saying that at t equals 0, this value starts as a 0, and e to the 0 just equals 1. So that means it's 1 minus 1, so it starts with 0 velocity. But as this approaches infinity, this e value is going to grow smaller and smaller because it's a negative exponent. It's going to go be divided. It's going to get smaller and smaller, meaning that this value is going to approach 1. So that means as you approach infinity, v is going to approach mg over b, which is what we determined to be the terminal velocity. Okay, I hope you guys found this helpful. This big derivation is kind of the most important thing, I would say. As long as you know how to do this, you're probably okay. I'll see you guys next time.